Good morning, chemistry students. This is Mrs. Krumschreider, and we are going to take a look at our Chapter 4 Day 1 notes. So today we're going to start to talk about how to solve these problems. And the problems we look at today, I realize that setting them up the way I'm going to ask you to set them up, that you don't really need to set them up to figure them out because they're pretty simple ones that involve the metric system and you could just move your decimal place. However, this is getting us ready to transition into Chapter 7. And in Chapter 7, we're going to be dealing with moles and molar mass, and you simply will not be able to move decimal places. You will need to know whether you need to multiply or divide by numbers. So I'm requesting that you please humor me and learn how to set up these problems when they're simple, like they're going to be today and tomorrow, so that when the problems get a little bit more complicated, you're not stuck on how to set up the problems. So this section is called Simple Conversion Problems. And we're going to start with the definition of conversion factors. And actually, it's not per se the definition, sorry, but we're going to talk about sort of the use of conversion factors, okay? So the idea behind conversion factors is that oftentimes a quantity, right, or amount can usually be expressed in several different ways. An easy example to think about with that is to think about money, right? With money, there are several different ways you can have a dollar. You can have $1 bill. You could have 4 quarters. You could have 10 dimes. You could have 20 nickels. You could even have 100 pennies. Okay? But they are all the same amount. And in fact, you could have some combinations of quarters, dimes, nickels, and pennies to get a dollar, as you're well aware, okay? But what we're talking about here is these are all different ways to express the same quantity of $1, okay? And this isn't just unique to money. It's also true within the metric system. 1 meter is the same as 10 decimeters, which is the same as 100 centimeters, which is the same as 1,000 millimeters. They're all the same length. If I ask someone to take a 1 meter step, or a 10 decimeter step, or a 100 centimeter step, or a 1,000 millimeter step, I would be asking them to take the same distance or length step. There's just different ways to express the same amount, just like there is within money. So there are going to be times when we have 2 measurements that are equivalent, right, or equal to one another. Then you can have a ratio of the 2 measurements will be equal to 1, or it's also called unity. So when we want to have these ratio of two measurements in chemistry class, that's called something special. That's called a conversion factor. So a conversion factor is a ratio, and this is really our definition of a conversion factor, of equivalent or equal measurements. In a conversion factor, the measurement in the numerator, which is the top of a fraction, is equivalent or equal to the measurement in the denominator. So that's what a conversion factor is. It's when you have a measurement in your numerator and it's equivalent to the measurement in your denominator. An example of this, of what a conversion factor might look like, is 100 centimeters over 1 meter. Okay? Again, 100 centimeters and 1 meter, that's the same length. Now, part of the power of these conversion factors is that they always can be flipped depending upon where I need my units to be. So I also could write this conversion factor as 1 meter over 100 centimeters. And this is going to be a really important idea and concept when we're solving these problems that we're going to learn how to solve. Okay. Conversion factors are useful in solving problems in which the given measurement must be expressed in some other unit of measure, which is pretty much all the problems we're going to be doing. Okay, so the kind of characteristic of these problems is that you're going to be given some number in a particular set of units, and you're going to be asked how many of this other unit do you have. Okay. When a measurement is multiplied by a conversion factor, the numerical value is generally changed but the actual size of the quantity measured remains the same. So this is the idea behind using these conversion factors. Okay, we're changing our numerical value, but we're not actually changing the size of the quantity that we've measured. And because we've talked about significant figures, we will have to pay attention to significant figures. Conversion factors, okay, are defined, or we can say that they're definitions. And remember, there were 2 times when we had unlimited significant figures. One of them was definitions. So, conversion factors have unlimited significant figures. So what that means for you is that you're never going to look at your conversion factors to determine how many significant figures your answer should have. You'll always just look at how many were you given to start with, okay? And so therefore, how many significant figures should you have on your answer? So that's what a conversion factor is. The process of using these conversion factors to solve problems is called dimensional analysis. So the definition of dimensional analysis, which is also sometimes called the factor label method, dimensional analysis is a way to analyze and solve problems using the units, which are also called dimensions, which is why it's called dimensional analysis of the measurement okay. So in this type of problem solving, we are going to use the units as if they're algebraic letters. Okay, so to kind of remind you, okay, what I'm talking about here, back when you first learned algebra, if you had 4a over c and you were multiplying it by c over 2a, right? When you first learned to do a problem like that, you learned that the c's are going to cross out because they're in the numerator and the denominator. The a's are going to cross out because they're in the numerator and the denominator. And you probably also learned that because this, and so actually the answer to this problem is just 2. Okay? We're going to treat our dimensions, our units, like these A's. And we're going to make sure that they are crossing out. So, to look at an example, how many seconds are in a workday that lasts exactly 8 hours. Now, again, many of you know how to do this without dimensional analysis, and I get that. But our problems in Chapter 7, you will not just know how to do. They're not going to be math problems you've done before. So I really need you to learn right now how to set up these problems. So one of the things that I always sort of like to do is I like to summarize this because I don't really like story problems, and probably most of you don't either, right? And this problem is asking me 8 hours is how many seconds? So in these problems, I'm always going to start with my given, okay? So my given is 8 hours. Now again, I'm treating my units like their dimensions, like I want them to cross out like algebraic letters. So I need to put hours on the bottom. I'm trying to go to seconds. What's something I know pretty easily about hours? I know about minutes. I probably really don't know off the top of my head how many seconds are in an hour. Okay, so notice my hours have crossed out, and now I have something in minutes. And I like to go through all my units first and then come back and fill in numbers. It doesn't matter, you don't have to do it that way, but that's normally how I'm going to do problems because it allows me to kind of keep with my train of thought. So I have minutes, but I need seconds, right? And so I'm not done. And minutes are in the numerator, so to cross off, they have to go in the denominator. So I'm going to put minutes in the denominator. And what can I easily convert minutes to? That I can convert to seconds. I know something about minutes and seconds. So now I see I'm going to be left with seconds, which is what I want. Okay, so I know that I'm done in terms of my conversion factor. So this is a conversion factor, and this is a conversion factor. Okay. Now, what about numbers, right? Well, 1 hour is 60 minutes, and 1 minute is 60 seconds. Now, I need you to remember, right, back to math class again. Numbers that are in our numerator, we're going to multiply by. Numbers that are in our denominator, we're going to divide by. Okay, notice here, all my numbers are in my numerator. So many of you probably knew how to do this, but if for some reason you didn't, right, I'm going to take 8 times 60 times 60, and I get a number of 28,800. Now, again, it's science class, chemistry, so we have to have a unit on this, so I have to say that it's seconds. Okay? Now, again, it's fine if you want to write this in scientific notation, 2.88 times 10 to the 4th. It does not matter to me whether you put it in scientific notation or not. I will never count it wrong or right based on the fact that whether you put it in scientific notation or not. Now, when we do problems like this, typically problems like this are going to be worth 4 or 5 points, depending. This one would be 4. Okay, so 1 point for having your answer, right, the correct number. 1 point for having the correct units. Okay, and then for this one, I would give you kind of 2 points for your work. So a point for having this conversion factor, another point for having this conversion factor. And then I would also have a point for significant figures. So this would probably be a 5-point problem on a test or quiz. Okay. Now, significant figures here, why did I use all of them? Because kind of this term exactly here, that means that I have exactly 8 hours. I could put 8 point, a decimal point, and put as many zeros behind it as I want. I want exactly 8 hours, which means really I have unlimited significant figures. Okay. So that's our first kind of example problem. I do want you to make sure when you're doing homework assignments that you're showing me all your work, which means do not type homework assignments. Hand write them on a piece of paper because typing up problems is a waste of your time. Okay? Hand write homework assignments and just either scan them with that PDF app, okay, that Adobe Scan app, or take a picture of them. Just if you're going to take pictures, I really do like that Adobe Scan app better because it's much clearer than your picture is. So if you have a smartphone and you haven't tried that free Adobe Scan app, if you would do it once and see if it works pretty smoothly, okay, for you, because it's definitely easier for me to read. But I need to see all your work exactly like this. So we use dimensional analysis to convert between units. So dimensional analysis is a powerful tool for solving conversion problems in which a measurement with 1 unit is changed to an equivalent measurement with another unit. Now, yes, I know I'm really picky. I'm telling you right now, when you take a note quiz over this at some point, if you just give me an answer, you're going to lose a whole bunch of points. I am forcing you to try dimensional analysis, to give it a good effort and use it. Why? Because actually, right, some of you are like, what of this chemistry that I've learned am I ever going to use? Right? Unless you're going to college and taking college chemistry, most of what we're learning in chemistry you're not going to use in the real world. I agree. I admit that, okay? However, dimensional analysis actually is something you can use in the real world. I never can remember the distance, rate, and time equation, but I can do those problems without the equation using dimensional analysis. Another example of this, some of you are interested in becoming physicians and nurses and such. Okay, my husband's a registered nurse. When he took his pharmacology class, okay, he was upset because sometimes he got the right answers and sometimes he didn't. And he was doing it the way that the teacher had taught him how to do it, his professor. And he was really concerned because in pharmacology, you're talking about administering drugs to people in the hospital. And he was also in clinicals at the time and supposed to administer drugs. Well, some of these drugs are for pain. Okay, probably the most common ones that are given in kind of an IV drip oftentimes are pain medications. Well, you don't want to give too little pain medication. You don't want to give too much because you might kill someone. And he could not consistently get the correct answers when he was doing these problems in class. And he was really worried because he did not want to not give someone enough of their pain medication or to overdose them on their pain medication. So I asked him, I said, hey, let me take a look at your what you're doing. And I looked at it and I said, I can teach you a different way to do this. And you, if you take the time to do it, and it doesn't take a real long time, but if you take the time to do it, you can feel confident that your answers are correct. What I showed him was dimensional analysis. From there on out, when he did his problems in pharmacology class for his quizzes and his tests, He got them correct. He didn't do them the way his teacher, his professor had taught him. He did them the way I showed him, but he always got the correct answer. And when he became a nurse and he had nursing students coming in and struggling with the same thing, he said he took the time and he showed them how to do the problems using dimensional analysis. So this really is one of the few things in this class that you actually may use outside of chemistry. If you take a physics class at some point, you can do physics problems with dimensional analysis and such. So I know it's annoying, especially with these easy problems. And if they're easy enough that you don't need to put them in your calculator, that's fine. All I'm asking is that you show your work the way I've asked you to show your work. So let's take a look at some example problems. Okay, and I'm not going to put these in fancy words, right? All the problems you're going to do in chemistry are going to be story problems, okay? But I'm going to kind of cut to the chase. Our first one here, we want to take 0.044 kilometers and figure out how many meters that is. Now, this does depend upon the fact that you know your metric system. So remember that metric system. King Henry died by drinking chocolate milk. You do need to know this metric system, okay? And remember in chapter 3, we did a couple and you kind of learned how to use this initially. We're going to continue to use this now. So, again, I'm always going to start with my given. Oops, but I need to write it correctly. So 0.044 kilometers. Where do kilometers have to go so they'll cross out? On the bottom. What am I trying to convert to? Meters, so that's going to go on the top. Kilometers are going to cross out. I'm going to be left with meters. So now I need my numbers, right? So remember the deal with this is I want to know which is larger, a kilometer or a meter. Kilometers here. Meters my base, so kilometers bigger. Remember, whatever one is larger, I'm going to make it equal to 1, so I'm going to say it's 1 kilometer. Then, how do I figure out how many meters? Well, I start here and I count. Oops. So I'm here 1, 2, 3. Okay, so that means I'm going to be 10 to the third. All right. So then I can just put that in my calculator if I need to, or if you don't need to, that's fine as well. And you get 44 meters. Now let's talk about whether or not that's correct in terms of significant figures. Okay. So 0.044, this number here has 2 significant figures, and this answer has 2 significant figures. So this is right in terms of significant figures as well. All right, let's take a look at another one. And it looks like we're going to do 3, 6, 7, 8 different examples. Okay, 4.6 milligrams is how many grams? So again, I start with my given, 4.6 milligrams. Milligrams is in the numerator. It goes in the denominator, right? You could always write these as over 1. I just don't do it that way, okay? So milligrams is in the denominator, so grams is going to go in my numerator. Milligrams is going to cross out. Grams, let me see here if I can erase a tiny bit better. All right, so grams is my base, milligrams is here, so my grams are larger, so that'll be 1, and 1, 2, 3, so grams was bigger, milligrams is smaller, and it was 10 to the third. Now, up here, right, because this was in the numerator, we multiplied. This time, because 10 to the third is in the denominator, we're going to divide. Okay, that's going to be important because, again, eventually we're not going to just be dealing with numbers as simple as whether, like, that we could just move decimal places. So our answer for this one is 0.0046, and again we have to have our units. Again, if we take a look at significant figures, okay, this has two significant figures, so my answer has to have two significant figures, which it does. Remember, these zeros are just placeholders, so they are not significant. So there's our answer for that one. All right. Again, I'm going to put my metric system over here. Okay. Our next problem, 0.107 grams is how many centigrams? So again, I start with my given. Grams have to go in the denominator to cross out. Centigrams are what I'm converting to, so that'll go in the numerator. Grams are larger, it's my base. And 1, 2, which is also, the other way I can write that is a 1 with 2 zeros behind it. Okay. Shoot. There we go. Right. A 1 with 2 zeros. Again, because I'm in my numerator, I'm going to multiply. So basically that means I'm going to move my decimal places 2 places to the right. So that means my answer is 10.7 centigrams. Again, in terms of significant figures, I have 3 significant figures here. The 1 and the 7 are significant because they're not zeros, and this 0 is significant because it's between them, and this also has 3 significant figures. My next problem, 15 centimeters cubed equals how many liters? Now, this is a good one to do because centimeters cubed isn't on here. This is something I do expect you to know, that 1 centimeter cubed is the same as 1 milliliter. And just so that you know, 1 cc is the same as 1 centimeter cubed. So those of you who live on a farm and perhaps you have given an injection of some medication to one of your farm animals and you've made that measurement in cc's, that's the same as a milliliter. So in this problem, we're going to start with 15 cubic centimeters. And again, cubic centimeters have to go in the denominator. What I can easily convert cubic centimeters to is milliliters. But the problem is this time, that's not what I'm asking for, right? I want liters and I have milliliters. So milliliters have to go on the bottom, but I can convert those to liters using my metric system. So now I'm going to be in liters. So now I'm going to come back and fill in my numbers, and milliliters and centimeters cubed is just 1 to 1. And with liters and milliliters, my liter is larger, and it's my base, so 1, 2, 3, a 1 with 3 zeros behind it, or you could write it as 10 to the third. Either way is the same. And again, I'm going to multiply by these numbers up here, but remember, multiplying by 1 is silly. Please, I hope you don't put that in your calculator, right? And I'm going to divide by these numbers down here, and again, I don't need to multiply 1 by 1,000. So basically, I'm taking 15 and dividing it by 1,000, which means I'm going to move the decimal 3 places to the left. So my answer is going to be 0.015 liters. Again, in terms of significant figures, 15 has two significant figures and 0.015 has two significant figures. So I'm good in terms of significant figures. The next one, 7.38 grams is how many kilograms? So again, I'm going to start with my 7.38 grams. I always start with my given. Grams have to go on the bottom to cross out. Kilograms have to go on the top. A kilogram is larger, so I'm going to make that 1. And here's my kilograms, so 1, 2, 3. So that's going to be a 1 with 3 zeros, or 1,000, or I again could write it as 10 to the third. I'm going to be dividing, which basically means I'm going to be moving my decimal 3 places to the left. So I'm going to have 1, 2, 7, 3, 8 kilograms. Okay. Again, in terms of significant figures, okay, this has 3 significant figures, and this has 3 significant figures because, again, remember, these 2 zeros are just placeholders. All right, we're going to do 3 more problems. Our next problem, we have 6.7 seconds. We want to know how many milliseconds that is. Again, we're going to need our metric system. Okay. So we're starting with our 6.7 seconds. Seconds have to go on the bottom. Milliseconds are going to go on the top. A second is larger, so I'll make it 1. Millisecond is 1, 2, 3. Okay. So I'm going to write a 1 with 3 zeros behind it, which basically means I'm going to move my decimal place 3 places to the right. So I'm going to have 6,700 milliseconds. And again, in terms of significant figures, this has 2 significant figures. And this also has 2 significant figures because remember, this is that understood decimal, so these zeros here are not significant. All right, the last 2, and these are ones that you will see some problems like this possibly on your homework when you have a homework assignment. So 14.8 grams of boron to, or we'll say use our equals again. How many cubic centimeters of boron? And the density of boron is 2.34 grams per centimeter cubed. So again, what I'm going to start with is my 14.8 grams of boron. Grams of boron has to go on the bottom. Centimeters cubed of boron goes on the top. Now, here I'm going to use this information. And notice that 2.34 is in front of grams. So in front of grams, I'm going to put my 2.34. And in front of centimeters cubed, when there's no number there, it's like a 1. Okay? So should I multiply or divide, right? Because this one isn't as simple as just moving my decimal to the left or to the right. And this is what the problems in Chapter 7 are going to be like. So this is why it's so important you understand this. Should I multiply or should I divide by the 2.34? Right? I should divide because it's in the denominator. So on my calculator, I'm going to take 14.8 and divide it by 2.34. And how about significant figures here? This has 3 significant figures. This number also has 3 significant figures, so my answer should have 3 significant figures. So my answer should be 6.32 centimeters cubed of boron. Okay, one more sort of like that. So we have 50 cubic centimeters of some cough syrup. We want to know how many grams of the cough syrup we have. And we know that the density of the syrup is 0.950 grams per centimeter cubed. So again, I start with my given, which is 50 cubic centimeters. Centimeters cubed have to go on the bottom, grams on the top. So my 0.950 goes in front of grams and 1. So this time, should I multiply or divide? Right? This time I should multiply because this number is in the numerator. So again, I'm going to do 50 times 0.950, and I get, and if we talk first too about significant figures, right, this has 3, this number actually has 3, so my answer should have 3, so I get 47.5 grams of syrup. So again, what's important here is that you're starting to learn how to set these problems up and recognizing that you're going to multiply by numbers in the numerator and divide by numbers in the denominator. You don't have any homework today, so enjoy your day. I will talk to you later. Have a great day.